We start out super simple with just the basics of perimeter and circumference. These are things that probably we did or you would have done in many grades earlier. And so some of this stuff is quite simple. First of all, in our unit here, we will deal with different kinds of dimensions. The dimensions of perimeter and circumference are just singular units. When we move into area, we'll talk about square units. And when we talk about volume eventually, we'll talk about cubed units. But in our current situation, all we're really looking at is the business of perimeter and circumference. In the case of a square, you know that it's just 4 sides. That makes that very simple. It is also the same in a rectangle, but you also know that a rectangle has 2 opposite equal sides. And so sometimes it gets a little specialized formula, but it's still adding up all of the sides. And a triangle, as you know, would be to add all 3 sides together, would be its perimeter. And then if we ever deal with a regular polygon, we can just say it just like the square. It's how many sides times the length of one side. And so a pentagon, in this case 5 sides, would just be 5 times s. These are just basic formulas, though, that you can use in any perimeter. Circumference is basically a perimeter, but it's a perimeter of a circle. But the proper terminology really is circumference. And so when we say circumference, we're talking about walking around that outside of that circle once, or in this case, this particular one, just one time. And we learn that there's a sweet little relationship here, that the circumference is pi times the diameter. Now this is really actually quite a fascinating phenomenon, that no matter the size, so again, circles are similar, whether they're this one or this one, they grow proportionally, and their diameter grows proportionally with them. And so no matter how big or how small, it doesn't matter, it will always be pi diameters that fit around that circle. So if you laid out the length of that circumference in a straight line like this, if you took that circumference and laid it out, you would get 1, 2, 3.1415, off it goes, pi diameters. Whether it's a little circle or a large circle, it is that pi value. And we can use that formula to solve all kinds of basic little problems. Here's a couple of quick ones. Let's just do this. So here, they want us to find c. c equals pi times diameter. We do not know c. We have pi. Our diameter would be 8, notice, because I doubled the radius. And actually, the circumference is 8 pi. Now, you can turn that into a decimal, but that actually is a very acceptable answer. If you're using pi, listen to me carefully, use the pi key on your calculator. And maybe let me just turn it quickly into a decimal for us. It would be 25, again, we use the approximate symbol, 25.13 centimeters. But honestly, you guys, if you can just leave it in this format, that's perfectly fine. If you're entering it into Canvas or another place, you probably have to go to a decimal, but that's okay. In the next one, you'll see that it gives us the circumference and wants the diameter. That's kind of like working backwards. Circumference is pi times diameter. They give us that it's 15.5 pi equals pi times diameter. And guess what? Let's solve for d. So we divide both sides by pi. And it turns out that there's our answer there. The diameter would just be 15.5. This last one, let's find a little space for it as well. This says find c, also a very simple question. C would be pi times the diameter, and 12 is the number, which is just 12 pi centimeters. That would be the circumference, walking around the circle once. And maybe just quickly to get that as a decimal, if I was doing that as a decimal, I get 37.70 as an approximate 2 decimal rounding. But the truth is you're in high school, and when you get to high school, you don't do the perimeter questions that you once did as a middle schooler, or even earlier, potentially. And so let's start looking at some better kinds of questions. First of all, if I was wanting perimeter, I notice that I have this length. I notice I have this length. I notice these are the same, and I have these. I have some missing lengths here. I do not know this, and I do not know this. I can use some other lengths to help me out. For instance, this 11 from top to bottom minus this 2 leaves me with my answer of 11 minus 2 means that this is 9 would be what's left over. I can do something similar to that. This is 8 from here to here. This little inlet here was 2, so 8 minus 2 leaves me with 6. So this would be 11 plus 8 plus 2 plus 2 plus 9 plus 6, and all of those just simply get added together to give us a total of 38, I believe is what it comes to. But all we're doing, again, you know what this is, 11, 8, 2, 2, 9, and 6 gives me the full perimeter of this shape. The perimeter of this trapezoid is almost complete. We have the 10, the 6, and the 18. The part that we're missing is, of course, this. Now, what I love about this is that you're like, how would I figure that out? Well, let's close this in a little bit. Let's drop down a perpendicular here. We would know that that's 6 because of this 6. This is 10 from here to here, which would leave 8 for the remaining part from here to here. Now, look, we have a little triangle, and it has a 6 on one side. It's a right triangle and an 8. And you and I could use the Pythagorean theorem here and solve for our guy here, and we would get 10. So what's nice about that is, let's add things together. 10, 6, 18 all the way along the bottom, and another 10. And when we add all of that together, we get the magic number 44 centimeters. This is so cool. I love that we have to use our Pythagorean theorem to pull off some tricks here. I must admit, I really like this question, and why I like it is because there's part of it that is usually forgotten by students. It's a very simple idea, but it gets forgotten. So let's watch to see what happens here. So remember, if we want to find the perimeter, we would want this half circumference, and then we would also have to add this part in together. So let's do half of a circumference. Circumference is pi times diameter. And so in our case, we would only want half of a circumference. So that would be 1/2 of pi times our diameter, which just simply is 4 pi. So this curved region here is 4 pi. And don't forget we need this. So the answer to the perimeter would be 4 pi plus 8. Now this would be the exact answer, as a matter of fact. And if you put that into a calculator and asked to enter it in 2 decimals, it would be somewhere approximately 20.57. The part that gets forgotten, of course, is this little 8 part. We get so caught up in doing the circumference, we forget that this is a part of our perimeter of our shape as well. I really like these kind. Again, there's a half of a circumference here, another half circumference here, and then there are 2 little 2 parts. So the big circumference would be 1/2 pi times the diameter of the big one, which is 8, looks like. So that would be 4 pi. So this half circumference is 4 pi. The other circumference would be 1/2, looks like 4 there, so that's 2 pi. So this is half of a full circumference, 2 pi. And then we would have the 4 from this little guy and this little guy. So if we add all this together, we get 6 pi plus 4 centimeters. That's a perfectly fine answer. That is an exact answer. But many of you want to go to a decimal. That's about 22.85 centimeters. Lots of fun with perimeter and circumference.